The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content. You can earn continuing education credits through ACI's online CEU program. Visit www.concrete.org to register. ACI conventions provide an opportunity for networking and for keeping up to date with the latest in concrete technology and practices.
We're going to do this by committee.
This is a recap of this presentation.
Right, and I'm not sure if he's going to
Let's go
discuss each one of them. Yes, I think he is.
Okay. So this is pretty much what I just said in the last bullet.
Yeah, let's give it a try.
Well, this is the next one.
Okay.
This
goes back. Okay, it was, as regarding being delayed, it was delayed. This spec is replacing the spec that was produced in 1995. So the 95 spec has been out for many, many years. The debate over core strength assessment took a while, and that has to do with the drilled cores. Is that not correct, Lars?
Yes.
Which overall in the big picture is not that big a deal. The biggest delay, perhaps the second bullet, were attempts to replace present core grades and come up with some method for determining acceptance criteria for encapsulation. And that has taken years and years. It's now approved by ACI. The anticipation is it will come out in the fall. It will be coming out for public comment shortly. And another key point, Shotcrete will be included in ACI 301. So the theme is that Shotcrete is a form of concrete, and all the specs that apply to concrete would apply to Shotcrete. As far as shortcomings, prescription-based versus not exactly sure what he was going to talk about there.
Well, he's talking about the negative or some of the shortcomings of the existing.
Performance-based, to go to board to a performance-based spec, as ACI is attempting to do. Restricts contractor innovation. As far as outdated technology, perhaps that he's going to talk about the new uses of the mixes and the wet mix technology, I would think. Outdated scope as far as responsibility of parties, and this gets into the quality assurance, quality control, not metric, the ASTM integrating. This spec does not accommodate fibers. Fibers is in a guide that the 506 produces. Incomplete checklist. We've struggled with the checklist. This is a specification, and there is a need for commentary, and according to what we've been directed, specifications in today's format do not allow commentary. And so the checklist is an attempt at commentary, and we'll talk later today on other presentations as to how commentary is going to be integrated into the Shotcrete documents. Again, Shotcrete is an alternate way to place concrete, so it should follow the same rules. It needs to go to a performance-based specification, sustainability, integrates new technology, needs to define responsibilities, and as regards contracts, as you can appreciate, Shotcrete has been an industry-driven process, and by industry I'm saying a contractor. Those people who know how to shoot drive the industry, and most engineers who write contract documents learn from those people. So it's not the same as concrete, where you have professors have developed and run mixes in labs and over the years have mountains of data, such as Professor Phil Ferguson at the University of Texas had. Any of his PhDs just had hundreds and hundreds and thousands of tests that were run.
Which one?
Contractors shall say what proposed to do, then what they said. You're the contractor. Let's go.
I think he puts a lot of emphasis on the submittals and how we're supposed to submit our process and then to comply with it. And then the other thing is this one, recognize that one size does not fit all. Kind of ties back into the previous core grading system.
Okay, this spec is a hybrid of performance-based and prescription. Again, there's no commentary permitted, so there is a need to reference the guide, and later today the guide will be, status of the guide will be presented. There's an emphasis on contractor submittals and contractor pre-qualification. In Shotcrete, pre-qualification is really the most important aspect of the job as far as working for quality assurance. 5062 has some default values if none are specified, and that regards compression and...
I think mostly compression, mostly.
Okay.
Compression and air content. Here, we have our speaker. Here, the stairs are over here.
We have imposed...
We'd be happy to turn this thing over like a hot potato.
Ladies and gentlemen, this is Phil Seabrook.
And we're sure glad
I understand Phil's been around for a long time. And seriously, somebody roped me into presenting a paper back in '85, and at that time Phil was a journeyman on the committee, and that was like, what?
Going on
20 years. Yeah, going on 30 years. We're on the new technology slide.
Okay. The new technology that we attempted to integrate into this standard is to allow the contractor the prerogative of selecting the system best suited, the Shotcrete system, best suited for the particular project. We had to accommodate the new admixtures, you see listed there, some of them hydration stabilizers, superplasticizers, cohesion agents, and of course now we see extensive use of silica fume in Shotcrete, and more recently the introduction of air and training agents, which we'll talk about in a minute. We have expanded the requirements for the pre-construction testing, and I'll explain why for that in a minute. We actually have acknowledged that you can actually entrain air in dry mix Shotcrete. It's being done in certain parts of Canada very successfully. There's people here that could speak to it. In our old documents or previous documents, it says that you can't do it, but you can. We of course got today much better pumps and robots, and we use hybrid mixers. There's mixers now available that can shoot either wet or dry, and so we had to be sure we accommodated this kind of thing. Okay, in order to implement this new standard, these are some of the things that the owner or the architect engineer has to address. You have to make a number of selections from the mandatory and optional checklist. Well, you don't have to make them from the optional, but you certainly have to make them from the mandatory. And really the document is designed to make effective use of the optional checklist also. And of course they have to be relevant to your particular project. You have to be set up to address the contractor's submittals, of which there are a very large number. You have to define your pre-qualification testing requirements, if any, but there's a great emphasis on the use of pre-qualification testing, including rebar encapsulation, which Jim, who was pinch hitting for me, is going to talk about here in a minute. You have to have, and this might be interesting how it works out, but you have to have a significant amount of lead time to prepare for the pre-construction testing. And that's, of course, fundamental to many of the performance-based specifications that are now being used on, well, most of our projects, but many projects in North America. And, of course, there's also a significant amount of cost in that pre-construction testing that goes up front. You have to define what you want for the QC from the contractor, and then, of course, match it with the QA from the owner. And one example there, we haven't got a. Thank you. One example is just an example that you've got to specify where you want the control joints to be located, if indeed you want control joints. And these kinds of things you've got to pick up in order to make effective use of this new document. From the contractor's point of view, it's necessary that you assemble a lot of the background information for your submittals, and there are a lot of them required, but you have to you just can't instantly create them. They require a little bit of preparation. If you're going to propose alternate methods, and certainly the specification allows that, you must be in a position to document that they've successfully, successfully been used. You have to have your nozzleman certifications in place. The 506.2 is presently, as we drafted it, requires nozzleman certification for structural shotcrete. It leaves the matter of non-structural open to the discretion of the architect engineer. And you must be prepared to implement effective and responsible quality control. And that sounds easy, but that's kind of my business, and that doesn't always happen. Some contractors understand quality control, and some don't. As it said earlier, the document says the contractor shall do the quality control, and we know that some parts of the country, the owner still wishes to do the quality control, and if so, that's fine, but you've got to make appropriate provision in your specification to cover that. There's just some examples of how we have accommodated performance-based specifications. We require certification of nozzleman, as I said, extensive pre-construction submittals, I've alluded to that. These are all part of most performance-based specs, and the bottom one I just referred to. Some of the submittals, and some of them, as it says at the top, are not applicable to all projects, but there's a long list there, and you've got to have the mixture proportions, including supporting test results that they comply with the specification. You have to submit your admixture types and the technical sheets that go with it. Mill certificates for the cementitious materials, aggregate qualification data, your experience in similar projects, including the experience of your crew, and those requirements are more demanding in the case of structural shotcrete, quite appropriately. The fiber reinforced shotcrete properties, if you're using fiber reinforced shotcrete, the certification of your QC testing agency, and repair procedures. And you may not have to submit, of course you're going to assume you're not going to have any repairs, but you may not have to submit the repair procedures up front, but there is provision in the document in that particular section that you have to submit them for approval of the architect engineer. This is just one little situation that we have identified. We make extensive reference to ASTM for all of our testing, as is the ACI policy. The ASTM C1140 requires, as you see on the slide, 2424 by 3.5 with either square or sloped sides on the panel. The ACI 506.2 requires 16 by 16 by 5 inches deep, and we don't have any specific requirements for the sides. And the little problem is that, you know, now we refer to C1140, and it has a different panel size than we say. We've developed a method of resolving this, and in the process of getting this thing, getting this standard finished, we're going to take care of that. The reason we wanted smaller panels is simply because of weight and the logistics of handling them on a construction site, and there's a safety element for the workers that got to handle them, and they get pretty heavy. The other thing we're concerned about is this requirement for 3.5 inches. We want 3-inch cores, and of course with 3.5-inch depth you don't get your L over D's of 2, which we prefer, and we're not overly enthralled by a 3.5-inch thick panel. So we got to sort this out, and of course we want to harmonize things with ASTM, and hopefully we will. Some examples of mandatory checklists. I won't belabor these. That you as the architect engineer, you've got to specify wet, dry, fiber reinforced, structural or non, and you have to specify type of reinforcement, obviously. Test panel orientation, and on this, we put default values in for a lot of these things. If you don't specify, then it says that they shall be shot vertical, and for most cases that's okay. But if you have an overhead project, you're going to have to specify that the panels be shot overhead. You got to specify the water cement ratio, which will depend on your particular exposure. We have a default value of 4,000 psi, a compressive strength. If you don't specify your own compressive strength, and although it doesn't say that up there, there's also a 400 psi default value for flexural strength for fiber reinforced shotcrete if you don't specify your own. And finally, you must specify whether you require air entrainment or not. Well, if you don't specify it, it wouldn't be required. So, further examples, any limits on supplementary cementing materials, any special properties that you want to specify for your project, bond, voids, and absorption, air void parameters, and so on. Dimensional and surface finish tolerances, of course, that's left to the architect engineer. What cover you require in rebar, this may be in drawings and so on, but it is a mandatory checklist, and any cold weather procedures that you might have. Now, the optional checklist, if you have special properties you specify, such as bond and voids and absorption, then of course you've got to stipulate your acceptance values for them, and you have to, as it's written now, define the criteria for rebar encapsulation. If you're concerned about that, and I'll just leave that to another paper that Jim's going to present. Little item, whether you'll allow non-potable water, not a big issue, but it relates to the wash water that many ready-mix companies are using. Whether or not admixtures are permitted or required, and the type of fibers if you're using fiber reinforced shotcrete. You can specify when there's a reduction in rebar spacing clearance, and the way that's written is that the contractor has to demonstrate in the pre-construction testing, presumably, that they can achieve the satisfactory encapsulation with some alternate forms of splicing. The code's written so that the rebar splices are supposed to be like this in the direction of shooting, but often, as you well know, they end up like this for practical reasons, and if so, you have to include that kind of thing in your pre-construction testing. whether or not your rebar can go through the construction joints, and if there are any other items that deviate from the specification and can be demonstrated as suitable in the pre-construction testing. And you probably get the message now that there's great emphasis on this pre-construction, and it's up to the contractor to demonstrate they're capable of doing it. And this appears in a number of areas in the specification. This is just one example. This is a rather simple one, but there's some parts of North America where they get temperatures over 95 degrees. If you get close to 95 degrees in our country, you just shut the job down. Nobody works. But anyway, there's some places they do, and we have a limit of 95 degrees for the temperature of the shotcrete, but then it goes on to say unless the required quality can be achieved at higher temperatures. And if a contractor can demonstrate that that works, fine. But that, of course, also gets built into the pre-construction testing or some subsequent version thereof. There's another example of how the contractor might want to take advantage of some innovation. It says stop shooting when ambient temperature is 40 degrees Fahrenheit and falling, unless, and you can read what it says, unless it can be demonstrated it can be protected. Now, we got a project, well, it's not running right now, but it was running not long ago where it only got up to, what's that, 550? It only got up to 40 degrees Fahrenheit. The highest temperature it got during the day, and we didn't have any problem shotcreting. We heated the mixing water, we heated the materials. It was a dry bag job, dry mix. And we had insulated tarps there and dropped them on just as soon as they finished shooting. And it went fine. So these kind of things, there's an attempt here to accommodate them. The only problem was when the winds come up, they blew the tarps off and froze the shotcrete, and that created another problem, but we'll just leave that. So in closing my abbreviated presentation, and again my apologies to Larry and Jim, if you simply say in your specifications, you Mr. Architect Engineer, that shotcrete shall be in accordance with 506.2, there's going to be a lot of holes. It's not designed to be used that way. You've got to at least go through the mandatory checklists. And we can no longer, and I think it said in an earlier slide, that we're no longer allowed to put a commentary in our specifications. So what we do is we have the guide to shotcreting, an excellent document that in effect becomes our commentary. And by referring to that, you can get guidance on all the items, including the items in the checklist. And you'll hear more about that later. And with that, I thank you for the time, and again, my apologies.